In this video, we're going to do a couple boxplot practice. So we're given the first question is in here. A new Five Guys opens up down the street. To convince employees to switch to the restaurant, they publish their current hourly wages, which are given in the chart below. So we're given a set of data, and it asks us to create a boxplot for the data. Whenever we're met those type of questions, the first thing we're going to do is to find the 5-number summary, which are minimum, Q1, medium, Q3, and maximum. So the lowest and highest value are here is pretty easy to identify, which are 17 and 25, since the question already given us the data in order, so we don't have to really dealing with that problem a lot. So the next thing is going to be find the median. So there's a formula for it, which is n plus 1 divided by 2. N is the number of data we're given. So in here, if you count that like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which n in this case is going to be 12. So 12 plus 1 and divided by 2, which we're going to give it, get 13 divided by 2, 6.5. And here, so remember, the 6.5 only gives us the position of the median. It's not the real median number. So we're gonna like count like from left to right, like how many like what is the value at 6.5 position is the median, which is 1, 2, 3, 4, 5, 6, 7. So 6 is going to be between 19 and 19.25. So if you add those numbers together and divide it by 2, you're going to get the median, which is going to be here 19.125. So we get the median right now. The thing that we're left is Q1 and Q3. So Q1, just think about it is in the 25th percent position of the whole data set. So if we find, like, just as we're dealing with the median, instead of divided by 2, we can divide it by 4. So then we can get that the Q1 is between 18 and 18. So 18 plus 18 divided by 2 is still 18. So Q1 is 18. And Q3 is going to be the 75th percentile of the whole data. So same thing, n plus 1 and divided by 4, but this time instead of counting from left to right, you can count it from right to left. So we get that Q3 is in between 19.5 and 20. So add those numbers and divide by 2, we get the Q3 is 19.75. So we get the 5-number summary in here. So what we're gonna do is just first draw a number line down here, which you can see from here. So, and remember to label the what are the x-axis stands for, which in this case is going to be Five Guys wages. And then everything is going to be a lot more easier. Remember that the box in here gives you the Q1, median, and Q3. And like those kind of like tails on like 2 ends is going to be minimum and maximum. And in here, this is going to be a outlier. Oh, I'm sorry, like I think I said like the highest value in here is gonna be 25. Well, it's true, like in two perspectives, like, but I mean, like, it's the highest number amount of data, but it's not the maximum number in here. The maximum is gonna be 20.5, and 25 is not gonna be actually in like the whole picture in here. It's going to be an outlier. And how do you define outlier? It's pretty easy. What you're going to do is that you count the IQR in here, which is Q1 minus Q3, and you get 1.75. And outlier from the lower end is going to be Q1 minus 1.5 times IQR. And this gives you this number right here. So if we see like the whole data in here, no data in here is less than 15.375, which means that we don't have lower bound outliers. So like I know like some textbook call this like fence data or like fence method, but like what like in any names you want to call it, I personally just prefer like to use it like it's pretty easy. So Q3 plus 1.5 times IQR gives you the higher bound outlier. So the higher bound is going to be 22 point something, and in this case 25 lies outside of the higher bound, which means 25 is going to be an outlier in this question. So in here, like, we draw our box plot in here, and yeah, and we don't have to like draw the y-axis in here because they didn't technically have an y-axis and it doesn't mean anything, so this is okay and this is perfect. It will gives you the whole point on the test. Okay, so let's move on to the second question in here. The 2001 World Alemic and the Book of Facts contains a section in which it lists noted personalities. These are arranged according to a number of categories, such as noted writers of the past and the noted scientists of the past. Distributions of the lifetimes of the people listed in 9 different categories have been displaced in the following box plots. So in this case, it gives you a box plot in here, and it asks you a bunch of questions down below. So yeah, so if we're just looking at the graph in here and we don't know, like, we don't care about the questions for now, we can see like most of the box plot, they typically have like the same range, or like they have like the main from Q1 to Q3. It seems like lies like not exactly the same, but they are pretty close to each other, and the medium is like fluctuate a little bit, but they're still kind of like in a same vertical line. So let's take a look at the first question. Which group had the individual with the longest lifetime of anyone listed? How many years about did he or she live? So it asks us for the longest lifetime for anyone listed. So in order to find this, we're basically gonna find, because the distribution is for the lifetime of the people, so we can find like which box plot have the longest range, which is from like, I think artists in this case have the longest because it's from like roughly 25 to about, I don't know, like 105 or something. So 105 or something. So I think our artists have the longest lifetime because you know, like, lifetime is like people's highest age minus the lowest age, which in other cases is the range. So artists have the longest lifetime, which in this case is roughly about 101. Yeah. So this is the first question. Which group had the largest medium lifetime listed? What is the approximately that value? So medium lifetime. Well, medium, we're gonna look at the bar inside the box for each box plot, and we can see that which box plot have the like the highest bar corresponding with the highest value, I mean. So if we take a closer look, we can see that probably business leaders have the highest bar, because I mean, business leader and scientists both have relatively like equal values of bars, but I would say it's business leader, or you can argue with me for scientist, whatever. Like, you just know that both of them seems like have the highest medium among those, and it's approximately 67. No, like 76. So part C, which group had the largest range of lifetimes listed? What is the approximately that value? So largest range of lifetimes, well, we already know that artists have the largest range, so it basically asks for the same thing, which is going to be artist same, and it's going to be 76. Well, okay, so I think the part A, the reason it's 101 is not because that is the largest range. It's because we want to know the individual with the longest lifetime. So we only cared about the maximum value, which in this case is going to be 101, corresponding with artist category. So yeah, artist is going to be the answer for part A, and same for part C, but they mean different things. Part C is the range. Artists also have the largest range, but in part A, we only cared about the maximum value. So sorry for my mis-explanation before. Okay, so part D, which group had the largest inner quartile range of lifetimes listed? What is the approximately that value? Okay, so inner quartile range, we know that IQR is Q3 minus Q1, and when it look like how is it looks like on a box plot, which is Q3 minus Q1, and Q3 always is the like right end of the box, and the Q1 is the left end of the box, which we just want to know like which box is the longest. In this case, it's going to be the military leaders. So military leader is approximately 25 because Q3 seems like 80 or something, and Q1 it seems like 55, so 80 minus 55 is going to be 25. Okay, so part E. Which group had the smallest first quartile lifetime listed? What is the approximately that value? So smallest first quartile, which is Q1, right? So Q1 is going to be the left end of the bar, and same is it is the military leaders because it has the lowest Q1 in here. And part F, describe the general shape of lifetimes across the groups. So the shape of the box plot, well, so when we're looking at the shape, we're gonna looking at like which of the how is the data distributed, like in what range is most of the data lie into. And in this case, we can see that most of the data are on the highest end, like pretty much like all in this part, and like there's only like it's like some of data is like lie in the lower end, which means that the shape is going to be skewed to the left, because skewed to the left in last video or like a couple videos before, we talked about if it's skewed left, then it means that it has a tail on the left side and less data is clustered in the left side and more data is clustered in the right side, and opposite for skewed right. So in this case, it's going to be skewed left for the whole group. Okay, so this is our second question. Let's take a look at the third one. And we're just going to continue practice because part like unit 1 is going to be a very fundamental topic like throughout your stats course, and the greatest thing in my opinion to learn a thing is through practice. So we're just going to do a bunch of questions, and I hope my explanation is making sense to you and you can learn something from it. Okay, so let's keep going. Comparing distributions. Question 3. Presented below are dot plots of distributions of hypothetical exam scores for several different classes. Part A. What strikes you as the most distinctive distance between class A, B, and C? Okay, so the difference, this question asks us to compare the three graphs in here. So this is for class A. Sorry for like the I think the font is too small. It's kind of hard to see, so I will zoom that in a little bit. So this is class A, and this is class B, and this is class C. So if you like draw the graphs a little bit, like roughly sketch it, just so you can see that the center definitely located different. Like A is approximately here, and B is here, and C is here. I mean, they're all approximately symmetrical, which means that they're roughly normal, but I mean, like C is probably, you can argue that it's skewed to the left a little bit, but roughly, like looking at the whole picture, they're all kind of normal. So normal, the shape is definitely not the part that we're talking about. So center is going to be quite different. So I would argue with center in here. So I just wrote like A is greater than B and is greater than C for the center. And the mean is approximately equal to the median, which means that the three graphs are approximately like normal. So if like the shape of the graph is like skewed to the right, then the mean is going to be greater than the median, and if it's skewed to the left, the mean is going to be less than the median. Okay, so part B, what strikes you as the most distinctive difference between class D, E, and F? Okay, so in this case, then it's definitely the range or the standard deviation is quite different. So this is class D, E, and F. So you can see just by looking at the graph, D has the most narrow shape and it's much taller than E and F. And F has the most like spread out shape, which means it has the highest value for standard deviation, and D has the lowest value for standard deviation. I mean, standard deviation is like you can say that standard deviation is like approximately equal to spread. Like how do you see the box plot, or like the I mean, you cannot really see like how the data are spread out, but you can sometimes. But it mostly just like presented on like a normal curve, or something like that, like this. So yeah, I would say that for the standard deviation, D is less than E is less than F. So F has the highest standard deviation. Okay, part C. What strikes you as the most distinctive difference among the distributions of scores in G, H, and I? So this is G, this is H, and this is I. So from here, we can see that G has approximately normal shape, and H is skewed to the right, and I is skewed to the left. Yeah, so I think, like, in my opinion, like the quickest way and the easiest way to do those type of questions is that you really want to roughly sketch a curve on top of each box plot, so then you can really, like, not box plot, but like for each like histograms, so then you can really see that how is the curve, like saying, like, you take many trials of samples, and you like take experiments on them, and you see like how is the final curve gonna be look like. So I think this is the fastest way for me, just to looking at, like, to see the distinctive differences for each. Okay. Let's move on to part D. What strikes you as the most distinctive feature of the distribution of scores in class J? Okay, this is a bit interesting, and you can see that it's not as same as like all of the graphs that we've seen before in this video. Well, this is going to be a bimodal shape graph, because you can see that there's there's two range of the data that's been clustered the most, and they just like located in different positions, and they have like two kind of like things just to bump out. So this is a bimodal shape. Part E. What strikes you as the most distinctive feature of the distribution of scores in class K? Okay, so class K, well, it has two outliers in here, right? And like most of the data is like a normal curve roughly, but they have like two outliers on both ends, like the lower end and the higher end. So that's the main difference. Okay.